Okay, so here's a wild thought. What if the key to making AI smarter isn't about teaching it to learn more, but actually teaching it how to forget? Sounds completely backwards, right? But stick with me because today we are diving into this amazing paper that did exactly that. They gave an AI this brilliant, intentional handicap, forcing it to forget the little details so it could finally see the big picture. All right, let's get right into it. So whenever we ask an AI to create an image, it's got this fundamental problem. You can think of it like an artist's dilemma. It's this constant battle between seeing the big picture, the main idea, and getting totally lost in perfecting every single tiny pixel. And yeah, this shows you exactly what I'm talking about. On the left, you've got an AI that kind of gets the idea of an image, right? You can see these blurry shapes, looks like cars, maybe some animals, but all the sharp details are just gone. Then on the other side, you could have an AI that's an absolute wizard with photorealistic textures. I mean, perfect detail. But it gets so obsessed with the pixels that it completely fails to create a picture that makes any sense. So this brings us to a really fascinating question, and it's the one that researchers were wrestling with. What if you could build an AI that was a master of detail? I mean, a true pixel-perfect prodigy, but it had absolutely no clue what it was actually painting. That was the challenge. Okay, so how do you solve a problem like that? Well, the researchers came up with this really brilliant way of thinking about it. They imagined they weren't just coding, but they were managing a team of two very different artists, a visionary master artist and a super talented but very focused apprentice. So let's meet our team. First up, you've got the master artist. This is the big picture AI. It thinks in concepts, the vibe, the essence of an image. It's thinking a cat on a boat. It is not worrying about the texture of the wood grain on the boat. Then you've got the apprentice. This one is a technical prodigy, an absolute master of detail. It can paint perfect fur, shimmering water, but it's super hyper-focused. It only sees the pixels right in front of its nose. So how does the master communicate with the apprentice? Well, it uses something called a latent code. And I know, that sounds super technical, but don't worry about it. For our story, just think of it as the master artist's secret blueprint. It's the simple, high-level plan that just contains the core idea. That's it. Okay, so the solution seems pretty obvious, right? Just team them up. Let the master artist hand over the blueprint, and let the apprentice go to town filling in all the gorgeous details. Simple, but well, this is where things get really, really interesting. I mean, the logic is sound. You've got the visionary with the big picture plan and the technical expert ready to fill in those photorealistic details. It should have been the perfect team up, a flawless collaboration. What could possibly go wrong? Well, it failed. And not just a little bit, it failed spectacularly. To quote the researchers directly from their paper, they found that the latent code Z is completely ignored. Turns out the apprentice was so good at just looking at the pixels right next to where it was painting and just improvising that it never even bothered to look at the master's blueprint. It just went completely rogue, painting these beautiful random textures that had absolutely nothing to do with the big picture. But this is the cool part. This massive failure, it led to the paper's biggest breakthrough. The researchers had this incredible aha moment. They realized this bug wasn't a problem they needed to fix. No, it was a feature they could exploit. And their solution was something completely counterintuitive. It was a brilliant handicap. So here's how they cracked it. Step 1, realize the problem. The apprentice wasn't bad at its job. It was actually too good. It was so skilled at just making things up on the fly that it completely ignored the master's plan. So what was the unlikely solution? They handicapped it. Intentionally. They basically put blinders on the apprentice, limiting its view to just a tiny, tiny patch of the image. And suddenly, it couldn't just guess what came next. It was forced to look up and consult the master's blueprint to get some context. And that is how we get the name of this whole thing, the Variational Lossy Autoencoder. The key word there is lossy. The master artist is now encouraged to create a lossy plan, a blueprint that purposely loses the fine-grained details. It's forced to forget them. Why? Because it can finally trust that its handicapped, but now very obedient apprentice will fill in all those details perfectly, all while following the grand vision. So the big question is, did this crazy idea actually work? Did handicapping the apprentice actually fix the problem? Well, let's take a look at the results and see what this new dream team could do. Oh yeah, the proof is right here. Check this out. On the left, you've got these original hand-drawn numbers. And on the right, that's the AI's version. And notice, it's not just a copy, not at all. The AI perfectly captured the substance, right? It gets the essential 4-ness of the number 4, but it came up with a totally new style. It's like it understood the concept and then decided to draw its own unique take on it. So cool. And what's really amazing is that this wasn't just for simple numbers. This same idea worked beautifully on much more complex photos. Look at this, originals on the left, AI versions on the right. The core structure is totally preserved. The deer is still a deer, the ship is still a ship. But the AI has completely reimagined all the local stuff, the texture of the fur, the lighting on the water, the exact colors. It is the master and the apprentice finally working in perfect harmony. And for all you data nerds out there, don't worry, I see you. This wasn't just a cool party trick. The numbers actually prove it worked. Here's a table from the paper. All you need to know is that their model, the VLAE, got a score of 2.95. And in this kind of test, lower is better. This was a state-of-the-art result back then, which means this wild idea wasn't just clever, it was seriously effective. Okay, so let's zoom out. Let's bring this all home. Why does any of this matter? Why is teaching an AI to forget such a big deal? Well, because it turns out this was never just about making prettier pictures. It's a key step in teaching an AI how to actually think. So what does a breakthrough like this actually unlock? Well, for one, it gives developers way more control. They can now tell an AI what's important to learn. It helps the AI separate what an object is from how it happens to look in one specific photo. This also leads to way smarter data compression. You just save the master's simple blueprint, not every single pixel. But the really big one, the most important one, is that this is a huge leap towards AIs that can reason more abstractly. Thinking in concepts, just like our master artist. That's the holy grail. When you really think about it, this whole paper teaches us something pretty profound. that sometimes the way to get smarter isn't just about cramming in more and more information. It's about learning what to ignore. It's about finally seeing the forest for the trees. And that leaves us with one last big question to chew on. If we can now teach an AI exactly what it should forget, what's the most important thing we need to teach it to remember?